Morning. Hi, good morning.
Good morning, sir.
Yeah, so very good morning. We'll just start with the class today. I think in the last class, if we can able to remember, we have discussed what was called as the proximity sensors. Okay, what type of proximity sensors we have discussed last class? What was
Capacitive,
okay, capacitive type. Okay, then
photoelectric,
photoelectric. Okay, fine, good. Then under photoelectric type, what are the different methods?
reflective, and through.
Reflective and
Through beam type, sir.
okay, right. Okay. So what are the different methods of what is that the capacitive type that you have done? What are the different methods of capacitive types that you have done? Capacitive transducers. What are the different ways by which you can design the capacitive transducers?
By moving the plate in y direction and
Okay.
x direction
Okay.
and material
The dielectric material.
dielectric material.
Yeah, good. Okay, right. Okay, and there is in that case, if you have moved the one of the plate in the x direction, there is some error which was used to appear. Okay, what is that error called as?
Non-linearity.
Error. Okay, right, fine. Now to convert that non-linearity into linearity, what is the type of transducer that you have used?
Push-pull type of capacitor.
Yeah, good. Okay, we have used what was called as the push-pull type of the transducers. Okay, right. Now, good. Now, these are all the various different ways by which you have used or you have done what is called as the capacitive type of the sensor. Okay, right. Now, we'll just continue now. Okay, continue for the next cases. Now, today we'll try to understand the one more type of transducer called as the light sensors. Okay, right. Now today we'll just proceed further now. Okay. Okay, right. Today is 13th, right? Yeah. Okay, right. Now today we'll try to understand what is called as the light sensors. Okay, we'll understand what are the types of light sensors, what is the basic principle behind this light sensor, how you can able to design the light sensor, and the three different methods of the light sensor we'll try to understand. Okay, right. Now the basic principle behind the light sensor is that now basically we'll be converting what is called as the photonic energy. Okay, we'll be converting photonic energy into what is called as the electrical energy. Now this is the first thing. Okay, electrical energy. Now the photonic energy is converted to electrical energy, and this effect, okay, is going to be called as the photoelectric effect. Okay, the effect which is responsible to make the light sensor is called as the photoelectric effect. Okay, so in photoelectric effect, we know that there is something called as the photons. Okay, photons converted into what is called as the electric. Photons is nothing but what? What do you mean by photon? Photon is nothing but what? It is nothing but your light energy. Okay, photon is nothing but your light energy. Now, in order to develop this the light sensors, basically, how are you going to measure? What is the input energy now? Input energy is what? Input energy is
Photon.
and the output that you are going to get is going to be the electrical energy. Okay, now, oh shit. Hello? Hello?
Yes, sir.
Yeah, sorry. Okay, there's some issue with my laptop. I'm now okay. Okay, right. Now we are just discussing about what was called as the light sensors. Okay, right. Now, one second. Yeah. Okay, we are discussing with respect to what is called as the light sensors. Okay, right. Now, basically the effect is going to be called the conversion is called as the photonic energy is going to be converted to what is called as the electrical energy, and the effect is going to be called as the photoelectric effect. The effect is called as photoelectric effect. Now, basically, the concept of photoelectric effect is going to be, as I told, we have what are going to be called as the photons. Okay, the photon, which is nothing but what is called as the light energy. Okay. Now, when the light falls on, okay, when the light falls on the material, okay, when the light falls on the material, what is going to happen is the electrons which are going to be present, okay, the electrons are going to be energized. Electrons will energized. Okay, electrons are going to be energized, and they are going to start to move. Okay, when they are going to start to move, there is going to be called as the movement of charges which are going to occur. Okay, movement of electrons are going to occur. Okay, that means what is called as the photonic energy. Okay, photonic energy is going to make, okay, what is called as the electron to move. Okay, when anything is going to move, what type of energy that you are going to get? Okay, any moving object will gives you what type of energy?
Kinetic energy.
Kinetic energy. Okay, any moving thing will going to give you what is called the kinetic energy. Now this is kinetic energy of what? Kinetic energy of the electrons. Okay. Now this kinetic energy of the electrons will leads to what is called as some electrical properties. Okay. Now this is related to electrons, there is going to be some change in the electrical properties are going to occur. Okay. Now this is very important. Okay. Now the stage is what? Now the process is nothing but here what is called as your okay, the process is nothing but your the photonic energy will make the electrons to move, which gives you what is called as kinetic energy. With the movement of the kinetic energy, there is going to be change in the electrical properties are going to occur. Okay. Now the basically electrical properties of the material changes. Okay, electrical property of the material changes. Now this change in the electrical properties, please understand, this change in electrical property is due to what? Is due to basically due to what? Basically due to what? What has made this electrical property to change?
Movement of electrons.
No. Basically, the movement of electrons is going to be intermediate one. Intermediate. Okay. What are the basic thing which is responsible?
Photons.
Photons. Okay. The photons are nothing but what? Photons are nothing but the light. That means the light is going to be converted into the light energy is going to be converted into what is called as the electrical energy. So that is the basic principle, and this effect is what is called as the photoelectric effect. Okay, the basic principle behind the light sensor is what is called the photoelectric effect. Okay, now before we understand the different types of sensors, now we'll be having three different effects are going to be there. Okay, three different effects are going to be considered to develop the light sensor. Three effects will be considered. Okay, will be considered to develop light sensor. Okay, to develop light sensor. Now which are those effects are going to be? The number one, first one is called as what is called as photo emissive effect. Okay, first one is called as photo emissive effect. Then second one is going to be called as photo conductive effect. Okay, second one is called as photoconductive effect, and third one is going to be photovoltaic effect. Okay, right. All are going to be what? All are going to be the based on what are called as photons. Remember, okay, right. Now in this case, okay, now I have just said previously that electrical properties are going to change. Okay, what do you mean by electrical properties? What might change? When I say electrical properties, okay, now voltage may change, okay, voltage of the material may change, okay, or the current passing through the material may change, or what is going to be called as the resistance might change. Okay, now these are the possibilities. Okay, there might be a change in the voltage, there might be a change in the current, or the resistance offered is going to be different. Now these three properties of the material will be considered in order to measure what is called as the light energy. So is it clear now? So when I say electrical properties, these are all the electrical properties which might going to change. Now next is we understood the three different effects. Now if I am going to develop a sensor by using photoemissive effect, those sensors are going to be called as the photoemissive sensors. Okay, right? Now photoemissive sensors, the results due to photoemissive effect, and then there is something called as photoconductive sensor. Okay, photoconductive sensors, that is going to be due to photoconductive effect, and photovoltaic effect leads to what is called as photovoltaic sensors. Okay, therefore, so we have these three are the three types of light sensors. Okay, now these three light sensors will going to be used by using these different effects. Okay, is this clear? The basic thing is clear to you now? Shall we proceed?
Yes, sir.
Okay, right. Okay, fine. Now we'll move on to what is called as photoemissive sensors. Okay, right. Now in case of photoemissive sensor, what is going to happen is there is something called as photo and emissivity. Okay, so photoemissivity, that means very simple. Okay, in this case, the photonic energy, okay, is going, as in all the cases, the photonic energy is going to be used for the conversion of light energy into the electrical energy. Okay, in case of photoemissive sensor, there will be emissivity of the electrons. Okay, from where? Now just observe, we have what is called as a cathode material. Okay, right. On this cathode material, what is going to fall? The light rays are going to fall. Okay, right. So what is this energy? This energy is called as the light energy. Okay. Now when the light energy falls on the cathode, the valence electrons, okay, the valence electrons which are going to be present here, the electrons which are going to be present here are going to be energized. Okay, the electrons which are going to be present here are going to be energized, and they start to move. When the movement is going to occur, we know that kinetic energy is going to be present. Okay, now this is the basic principle. Okay, now when the charges are going to be there, they will move towards what? Now we have a cathode, so the energized electrons will start to move, and where they will get collected? They will collected from the material which are released from the cathode. The electrons released from the cathode will collect at what is called as the anode, which is going to be a negatively charged or negative potential. Okay, right. Now here you are going to get what is going to be called as the current. Okay, the anode current is going to be developed. Okay, that we call it as the anode current. Anode current is going to be developed. Okay, the amount of anode current developed is going to be equal to the amount of light intensity. Okay, right. Now this can be understood by two different methods. Okay, one is called as, okay, so again under this photoemissive sensor we have two different types are going to be present. Okay, so number one is called as the tube electronics sensor. Okay, the first one is called as tube electronics sensor. Okay, the second one is going to be called as the solid state electronics, okay, light sensor. Okay, right. So we'll move to the second page. Okay, right. Now just observe. What is the first method now? What is the first method? First method is called as
Tube electronic.
tube electronics sensor. Okay, right.
Light sensor.
Okay, now next. Now in case of tube electronic sensor, okay, so there will be a tube, okay, simple, evacuated with vacuum. Okay, so this is going to be your the tube which is made from the quartz. We will be having a quartz tube, okay, and this is vacuum, okay, within which we will be having the vacuum. Okay, then we have what is called as this one. What is this called as? What type of material? So this is called as here the cathode material. Okay, right. Now there is something called as the anode. Okay, right. Now between this anode negative and cathode positive. Okay, right. Now this is the simple circuit. Now what is that you are going to measure now? Now as such it is the case. Now what is going to happen? The light falls on this cathode material. Okay, light falls on the cathode material. When the light falls on the cathode material, what is going to happen? Now the electrons are going to liberate from here. The electrons are going to emissivity. Okay, emissivity is nothing but emission of the electrons are going to occur. Those electrons with the amount of energy received, they start to move. When they start to move, where do they move is important. Okay, so these are the positively charged thing. They will move towards what? They will move towards the anode. Okay, and they will collect at the anode. Okay, now all the liberated electrons are going to be collected at the anode. Therefore, this movement of the charges, will get collected at the anode, and which results in what is called as the anode current, which results in what is called as the anode current, which is measured here. Okay, right. Now what is that you are measuring now? Okay, you are measuring what is called as the anode current. So this anode current is the measure of what? Is the measure of light intensity. Okay, so this is a simple case. Now please understand. So in this case, light falls on the cathode, which makes the electrons to liberate and attracted towards the anode. So negatively charged. At this point, you collect all the negatively charged particles are get collected at the anode, resulting in what is called the anode current. Okay. Now, what is the disadvantage of this is very important. Now, it depends. The amount of anode current depends upon what? Depends upon how many number of electrons are liberated. Okay, right. And the amount of anode current generated here is going to be very, very lesser. The amount of anode current generated is very lesser, and hence, so displaying is going to be difficult. Okay, display is difficult. Okay, now for that, now we have another method. Okay, this is called as your the tube electronic sensor. Okay, so this one is called as your the tube electronics sensor. Okay, tube electronics light sensor. Okay, right. Now the other method is going to be called as the solid state electronic sensor. Okay, right. So now we shall go with what is called as solid state electronics sensor. Okay, right. Now what we have now is, just understand, we have again a vacuum filled chamber. So this is a vacuum filled chamber. Okay, right. Now we have what is called as the anode. Okay, sorry, cathode. Okay, so this is the cathode. Light falls on this. Okay, so what is the effect now? So this is your cathode. Okay, this is your light. Okay, right. Now what is the effect? What is the effect of this? What is going to be generated? What will liberate? What will emit?
Electron.
Be louder, yeah?
Electron.
Are you understanding?
Yes, sir.
Okay.
Yes, sir.
Okay. Now what is going to be liberated? The electrons are going to be liberated. Let me say that the electrons have liberated. Okay. Now, what is that? Let's assume that I have placed an anode here. Okay. Right. So this is my anode. Okay. Right. So what should happen now? What should happen now? These electrons will move towards where?
Anode.
Anode. Okay. Anode, and resulting in what is called as the anode current. Yes or no? Yes or no?
Yes, sir.
Right. Now, The thing now is, please understand, the amount of electrons generated here is not having that much energy to give you sufficient amount of anode current. Are you understanding? The electrons generated will not have enough amount of the energy to have a sufficient amount of anode current. So what we'll do now is we will have some device. Okay, so we'll have some device which I will call it as dynode. Okay, please understand. Okay, so I am going to call this as dynode 1, number 1. What are dynode 1? Dynode 1 are called as photo multipliers. Dynode 1 are called as photo multipliers. Okay. Now, what is the purpose of photo multipliers now? What is the purpose of photo multipliers? Can I just guess?
Place the electrons.
Ah, no. One second. Yeah, tell me what is the purpose of photo multiplier? What it does?
To increase light intensity.
Huh?
To increase light intensity.
Okay, right. Now, what we require now is, okay, in order to get the anode, more amount of anode current, there should be more amount of electrons to be present. Okay, now what is going to happen now is the photomultipliers will be kept at a larger potential than this. Now, these electrons will be attracted towards this. These electrons, whichever is liberated, will attract towards this. Okay, and then there will be what? Liberation of secondary electrons. Okay, these secondary electrons liberated, please understand carefully. The secondary electron, the electrons liberated from the cathode will be attracted to the dynode, and the dynode acts as photomultiplier. It multiplies the electrons. Okay, now what is going to happen now? More amount of electrons are going to be liberated. Okay, now these amount of electrons, then again I want much more amount of this strength. Okay, then again what I will do, I will send them to another dynode. Okay, are you understanding? Now what is dynode doing? Dynode is giving more amount of energy. Okay, now again what is going to happen? Now there will be multiplication of the secondary, more number of secondary electrons are going to occur. Okay, now these secondary electrons liberated now will go towards what? The anode. Okay, now if you understand, without the dinodes, just an example, there were only two different types of electrons which were supposed to go to the anode. Okay, resulting in lesser number of the anode current, lesser amount of anode current. Now what has happened? Because of this presence of the dynode, which acts as the photomultiplier, there will be more amount of secondary electrons are going to be liberated. Now you can have that many number of dinodes. Okay, as many number of dinodes as possible, so that you will get some appreciable amount of the anode current. Okay, so now once you get some appreciable amount of the anode current, then you measure the anode current, which is the intensity of the light. Okay, now this is something related to what is called the photoconductive sensors. Okay, is it, sorry, photo emissive sensors. Okay, is this clear to you? Shall we proceed? Shall I proceed for the second one?
Yes, sir.
Right? Okay, right. Now the second one is called as, what is called as photoconductive sensors. Okay, second one is called as photoconductive sensors. Okay, right. Now just observe here. Now, in case of photoconductive sensors, the type of material, okay, the type of material what we are going to use is called as semiconducting material. Okay, so we are going to develop the photoconductive sensor by using semiconducting material. Okay, right. Now, what is the property of the semiconducting material? Is that, okay, the resistance, okay, resistance decreases with increase in light intensity. Okay, right. Now the resistance decreases with increase in light intensity. Now in the previous case, in the photoemissive sensor, what changes? What is your output? Output of photoemissive sensor? The output of photoemissive sensor is nothing but the anode current is that what you are going to measure. Okay, right. Now, in case of what is called a photoconductive sensor, you are going to use semiconducting material. The property of the semiconducting material is that the resistance of the semiconducting material decreases with increase in light intensity. Okay, right. Now, what are the semiconducting material that you are going to use? I am going to use what is called as the cadmium sulfide. Okay, we are going to use cadmium sulfide. We are going to use lead selenoid. Okay, we are going to use lead selenoid. We are going to use lead telluride. Okay, right, and lead sulfide. Okay, right. So these are the 4 different types of semiconducting material that we are going to use here. Okay, right. And these photoconductive sensors are also called as the light dependent resistor. Okay, so it's also called as light dependent resistor. Okay, so that is LD, light dependent resistor. It's also called as LDR, or it's also called as the photo resistors. Okay, it's also called as photo resistors, or it's also called as photo conductors. Okay, now these are the 3 different methods or the 3 different names which are there for what is called as the photoconductive sensors. Okay, right. Now, how the circuit is going to be now is important. Is it clear now? Now, in case again I am repeat. So the second method is called as the photoconductive sensors. In case of photoconductive sensor, we are going to use a semiconducting material, and here the resistance of the semiconducting material decreases with increase in light intensity. These are the different materials which we are going to use, and it's also called as the LDR, light dependent resistor, photoresistor, or photoconductor. Okay, right. Okay, right. Next is about the circuit. Okay, we'll just move on to page number 3. Okay, right. Now, okay, right. Now in this case, what we have now is, okay, so we know that what is the basic equation of voltage and resistance? V is equal to I into R. Okay, right. Now we told that there will be change in the resistance. Okay, this change in resistance, okay, is due to what? This change in resistance is due to what? Is due to the light intensity. Yes or no?
Yes, sir.
Okay, change in resistance is due to the light intensity. When resistance changes, automatically the voltage and the I is going to change. That is, voltage and the current is going to change. Okay. Now, in order to make up the circuit, okay, you can't make both of them are variable factor. Okay. Now you have to keep one as the constant and other is going to be measured. Okay. That means what? Now what I will do now is I will have a LDR now. Okay, this is the LDR material. That is LDR is nothing but what? What is the material's name? What are the material's name? Quickly. What is the material's name?
Cadmium sulfide,
Yeah, cadmium sulfide. Then
lead solenoid,
lead solenoid, lead telluride.
Sir.
Okay, lead sulfide, something like that. Okay, so conductive material. Now this is the LDR material. Okay. Now on this LDR material, what is going to happen is the light is going to fall. Okay. Okay. Once again. ಅಲ್ಲಿ ರಜಾ ಕೊಟ್ಟಿರ್ಬೇಕು ನೋಡಿ ಇವತ್ತು ರಜಾ ಕೊಟ್ಟಿದ್ದ ಮರ್ತಾ ಇದ್ದ ನಾನು ನೋಡಿ ಚೆಕ್ ಮಾಡ್ಬಿಟ್ಟು ಅಲ್ಲಿ ಸಿ ಎಲ್ ಬರ್ಬಿಟ್ಟು okay, so this is the LDR material. Now in this LDR material I want to build the circuit. Okay, now the circuit is going to be what I will do. I will have a constant current source. Okay, I will have a constant current source. Now if I have a constant current source, which is going to vary? Which is going to vary?
lights,
Huh? No, in this equation, V is equal to IR, correct? Na? V is equal to IR. Now light falls on this light dependent resistor. Okay, so you have what is called as light, correct? Okay, now when the light falls on LDR material, first of all, what is going to vary here?
Resistance.
Resistance of the LDR material is going to vary. Okay, that means what? R will vary. Okay, when R is going to vary, when R is varied, now either I both I and V should supposed to vary. Okay, so how I am build the circuit? Is it I have built the circuit for constant current or constant voltage?
Constant.
Constant
Current.
current. Okay, when I make constant current, now what is proportional now? I is going to be constant. So change in resistance will make what to vary?
Voltage.
Voltage.
Voltage to vary. Okay, now R is changing, I is constant, hence what is going to vary? The voltage is going to be varied. Okay, now what is this now? So now here you are going to measure what is called as the voltage. Okay, now the amount of voltage, okay, is a measure of what? The amount of voltage is a measure of change in resistance. That change in resistance in turn is a measure of what? In turn is a measure of what is called as the light intensity. Okay, right. So this is something called as the photoconductive sensor. Okay. Now in photoconductive sensor, resistance of the material is going to changes. Okay, this is very important. Okay, resistance of the material changes. Okay, so this is the principle of what is called as photoconductive sensors. Okay, right. Now we'll go to the last one called as what is called as the photovoltaic sensors. Okay, we'll go to photovoltaic sensors. Okay, so in this case of photovoltaic sensors, okay, so what is going to vary now, right? Now anode current has varied, that is the principle of photoemissive. Resistance of the material is going to vary, that is the principle of photoconductive sensor. Okay, in case of photovoltaic sensor, there will be a potential difference. Okay, there will be a potential difference across the junction when light falls on it. Okay, when light falls on it. Okay, so this is the principle of photovoltaic sensor. Okay, so it is photovoltaic. Okay, light energy converted to voltage. Okay, that is what now. So basic thing is light energy is going to be converted into what is called as the voltage. Okay, right. Now in this case of photovoltaic sensor, we are going to use the materials as diodes, or we are going to use what are called as the transistors. Okay, right. So if I am going to use a diode, what is the junction called as? Diode. You forgot everything. Okay, we call it as PN junction. Yes or no?
Yes, sir.
Remembering or not? Okay, PN junction with what is called as the anode and what is called as the cathode. Okay, so how to represent a diode? Any idea? How to represent a diode?
With arrow.
Huh? Diode. How to represent a diode? Yes, is it correct? Okay, now just observe, this is here the diode. On this diode, what is going to happen? The light energy is going to fall. Okay, right. Now this leads to what? This leads to the development of what is called as the voltage. Okay, the voltage is going to be generated. That's simple, as simple as that. Now the voltage is nothing but your the output, and this is your light intensity. Light intensity is your what is called as the input parameters. Okay, I'll just tell as simple as possible. Okay, now this is your photodiodes, right? So these are called as this is called as your photodiode. Now can I have an example for phototransistor? How many junctions are going to be present in phototransistor?
3.
3. Which are those?
PNP and NPN.
PNP, good. Okay, and we have what is called as NPN. Okay, right. Okay, now these are called as phototransistors. Okay, so the second one is called as phototransistors. Okay, which are the terminals? Can you tell me which are the terminals which are present?
Emitter base.
Emitter, correct. Emitter, base, and then
Collector.
huh?
Collector, sir.
Collector. Good. Okay, emitter, base, collector. Okay, right. So again, emitter, base, collector. Okay, right. Now here, what is going to happen now is, okay, right. Now the light is going to fall on this. In case of PNP or NPN transistor, the base terminals is going to be kept at a very lesser value. Okay, base terminal is going to be kept at a lesser value, or you can still say it's a negligible values. Okay, right. Now when you have a base current negligible, the light falls on the emitter, which makes the electrons to move. Okay, and you are going to collect the charges at the collector. Okay, so the voltage developed at the collector, the voltage developed at the collector is a measure of what is called as the light intensity at the emitter. Okay, now this is the basic principle. Just you have to write the basic principle, and then photodiode simple diagram like this, and a photo transistor diagram. Okay, right. So these are the three different types of what are called as the the light sensors which are going to be present. That is photoemissive sensor, photoconductive sensor, and photovoltaic sensors. Okay, right. Now this is about the light sensors. Okay, right. Then we'll move to the small subsection. Okay, so that is called as okay. Go to the fourth one. Okay, so we'll go and understand what are called as strain gauge based sensors. Strain gauge based sensor. Okay, right. Now quickly you tell me what for this is used. Strain gauge based sensors is used for what? Strain gauge based sensor. What for it is used? It is used to determine tell me what for strain gauges are used?
To measure strain.
To measure strain. Okay, right. So the output is going to be strain. Okay, the output what you are going to measure is the strain. Okay, next. What is that input that you are going to give? You might have given what is called as the displacement. This strain has occurred due to the displacement, or you might have applied what is called as the force. Okay, correct. Now, can you measure the strain as a mechanical parameter? If the strain is smaller, okay, try to understand carefully. I have applied a load, just observe. Okay, so this is my load cell. You have a load cell. Okay, I have applied some 10 kg of load. Let's say 1 kg. Let me say 1 kg of load I have applied. Okay. Now there will be what? Some deflection is going to occur. Definitely some small. Okay, I'm exaggerating. Okay, some deflection is going to occur. Okay. Now you are going to measure this. This is nothing but your change in deflection. Okay. Mechanically, how will you measure the deflection? Mechanically, how will you measure the deformation or the deflection? Okay. Any idea? If the strain is small, because strain is what? What is strain? What is strain, by the way? What is strain?
Change in length by original length.
Change in length by original length. Okay, so strain is nothing but change in length by original length. So original length will be known to you. Now, how to measure this change in length is the question. Okay, right. If I measure change in length, then you can able to measure the strain. But if the change in length is going to be very smaller, okay, if the change in length is going to be very smaller, it may not be possible for you to measure the change in length by using what are called as the mechanical devices. Okay, what is the mechanical device which is going to be used? If you can remember, there is something called as extensometer. Have you heard of this word?
Yes, sir.
Yes or no?
Yes, sir.
Okay, so extensometer. So maybe you might have used this in your the material testing laboratory. Okay, so extensometer. Okay, if you remember that you are done in case of your what the what is this one? What is this? What is this experiment?
Cancel test.
Yeah, you just do this. Then you mark 1, 2 points here called as the gauge length. In between this, you are going to place something. Okay, so that something what have you placed is called as your extensometer. Okay, right. Now extensometer is going to be used to measure a larger amount of strain. But if the measurement, if the strain is going to be smaller, okay, which is going to be in terms of microns, okay. Now in this case, it is not even to be seen. Okay, it is very smaller. Okay, in that case, in order to measure the strain which are very small, we are going to use what are called as the strain gauges. Okay, just remember, the strain gauges are going to be used to measure the very smaller amount of the strains. Okay, so that's why they're also going to be called as the micro strains. Okay, right. Now these strain gauges are going to be generally of what is called as the electrical type. The strain gauges are going to be the electrical type, and they are going to be called as the resistive electrical type strain gauges. Okay, these are called as the resistive electrical type strain gauges. Okay, right. So that is very important. Okay, electrical type strain gauges. Now, how the strain gauges are going to be? Is it a have you seen the strain gauges anytime? Yes or no?
Sir.
Okay,
Sir.
how is it going? Is it big or small?
Small.
Okay, the strain gauges are going to be very small. The strain gauges are going to be very small in thickness. So it is going to be of the order of 0.02 mm to maximum of 0.05 thick. Okay, so this is the strain gauge. Okay, this is how the strain gauges are going to be. Now just observe. Now, how are you going to? This is a filament like. Okay, so it's a filament like thing. Okay, it's a metallic filament. Okay, which is going to be metallic filament. Okay, filament is metallic. Okay, which is going to be of 0.02 mm to 0.05 mm thick. Okay, right. Now, how are you going to place? Okay, you are going to use what are going to be called as the resin. Okay, you are going to use the resin material so that these strain gauges are going to be cemented. Okay, are going to be pressed onto the member. Now just observe. So this is the cantilever beam. Okay, assume. Okay. So now I want to measure what? I want to measure the deflection. Okay, I will apply what load. Now I want to know what is the amount of deformation. Okay, again I am writing an exaggerated diagram for you to understand. Okay, I want to know this deformation. Okay, so for that I need what? I need to place my strain gauge. Therefore, the strain gauges are going to be placed. Okay, are going to be what? Are going to be cemented onto this by using what is called as the resin. Okay, so this is the basic concept of this. Okay, now whenever I am going to use what type of strain gauges are this? These strain gauges are called as the resistive electrical strain gauges. That means what is going to happen when I am going to say the strain gauges are going to be electrical type. So these will form what is called as the Wheatstone bridge network. Okay, these will form 4 arms of the Wheatstone bridge network. Okay, right. Now this is going to be your potential and this is going to be your galvanometer. Okay, so if I am going to say R1, R3, R2, and R4. Okay, right. Now when everything is correct without the application of the load, okay, now you are not applied the load. Now we have what is called as R1 by R2 will be equal to R3 by R4. Okay, what is this condition called as? Balanced bridge condition. Okay, right. Now this condition is called as the balanced bridge condition. Now, whenever the load is going to be applied, okay, when the load is going to apply, what is going to happen to the resistance? Will the resistance will remain same?
No, sir.
The resistance is going to vary. Okay, right. Now we know that with the application of the load, okay, with the application of the load, R changes. Okay, so the resistance is going to changes. Okay, now please understand the delta R is what? What is delta R? Delta R is the change in resistance to original resistance. Change in resistance to original resistance is proportional to what is called as the strain. Okay, it's proportional to the strain. Okay, now what is strain basically? What is strain basically? Strain is nothing but what? Change in Change in
Length.
to original length. Okay. Can you tell me what is the proportionality constant? If I remove the proportionality constant, what is that I am going to write? What is the proportionality constant called as? Yeah, what should I write here? Any idea? Tell me quickly. You might have done this earlier. Huh? Okay, right. So delta R by R is nothing but change in resistance to original resistance is proportional to the strain. So if I take out the proportionality constant, the proportionality constant is going to be expressed as G. Okay, what is G? What is G? G is called as
Gauge modulus.
huh?
Gauge factor.
Gauge factor. Okay, G is called as the gauge factor. Okay, therefore the gauge factor G will be equal to, it is the ratio of change in resistance to original resistance by change in length to original length. Okay, now this is the factor what we are going to use in the strain gauges. Okay, right. Now we'll have some more thing to do. Okay, that is we'll try to understand when we come in the 1050 class. We'll try to understand what are the different types of strain gauges which are going to be there and how to measure. Okay, how to measure the strain. Okay, small maybe 5-10 minutes is going to be still there for me to go through with the strain gauges. Okay, I think we'll stop at this time. Okay, hope the teachers will be waiting the next class. Okay, so I think we'll stop at this stage. Okay, so all of you are there. Yeah. Okay. Right. Fine. Okay. Right. Yeah. Okay. Right. Now I'll just stop at this class at this time. You'll be in the class for the next hour.